Hey everyone, it is time for another recitation. This time it's going to be a bonus one going over some Postgres stuff. This isn't going to be super highly structured. I kind of want to go over a little bit of Postgres administration, how to connect to it within our projects, and then some of the cool things that Postgres offers us. Um, so first of all, what is the difference between SQLite and Postgres? Well, SQLite is designed to be an embedded or in-memory database. So it really lives alongside our application and is great for development because it's very easy to set up. It's great for embedded devices that we don't necessarily want to run other processes on. It's also very common in mobile development to have a user-side database storing data. SQLite is wonderful. It's very powerful, but we don't see it in deployment that often, even though you can absolutely use it there. What's more common is slightly more powerful DBMSs like Postgres, MySQL, Microsoft SQL Server. Postgres is arguably the most advanced of the free and open source databases, and some would certainly argue even beyond the free and open source ones. It's a really wonderful database that offers us a lot of power, a lot of ability to scale, and a lot of cool functionality that SQLite doesn't have, either because they haven't implemented it or because SQLite by design just doesn't check all the same boxes that Postgres does. I'm going to be only showing a small amount of that today, but hopefully I'll talk about some stuff that is going to cue your interest in looking into some other features as well, because SQL has an incredible amount of depth, that I certainly can't get through in an hour, and I certainly don't even know already. But the important thing that I want to focus on today is really, if you can, how to use Postgres, some different ways to use it, because next week in your build weeks, when we deploy to Heroku, in order to get a persistent database, we need to use something that isn't SQLite, because Heroku doesn't persist the disk storage that we have, so your SQLite database will wink out of existence as soon as the Heroku container stops. Whereas you can use a free version of a managed Postgres instance on Heroku in order to get a persistent database. And so we'll show you how to set one up locally so you can test with it. I would still recommend doing all your projects this week with SQLite because you're not really going to run into any significant differences between the two. But for build weeks, you might run into a situation where your SQL is incompatible, and it can be easier to test on a local Postgres install than by pushing commits to Heroku constantly and seeing if they fail once it's done rebuilding. Okay, that was a lot of preamble. So what I have for us today is an adaptation of my build week project. Because I ran into a situation where I really wanted to use some features that Postgres had but weren't compatible to SQLite. So I had to use Postgres locally. And there's a couple ways to do this, and I posted them in the channel. And I'm curious what people were successful with because I use Linux. I was able to test a small amount on Windows over the weekend, but I don't know how much actually worked for you all. So what we have here inside of our Nextfile.js is where we describe the connections to our database, the options that we want to use. So normally for development, we would have an object specifying our connection to SQLite. And our connection is just a file name, right? That's where the SQLite database is going to live. Then we can also specify our migrations and seeds and some other default options. If we want to use Postgres, we simply modify or add a new object, but this time the client is going to be PG. Now, the client previously was SQLite 3. This is going to necessitate a new dependency, where previously we would run yarn add SQLite 3. When we're using Postgres, we will run yarn add PG, That's all that takes. Same configuration options with some of these things, like use null as default, how we specify our migrations and our seeds, but the connection is going to look slightly different. Now, there's two ways to describe a connection to Postgres. One is using this connection object, where we have to specify some additional pieces of information, because Postgres is not merely going to be a file on our computer containing our database. It is going to be another, essentially, server that is running, and we have to communicate with it over a network. So we have to specify what port that it is running on, and by default, it's going to be 5432, and if it is, you can just leave that there, just fine. Or I'm sorry, you can just omit the port, because Postgres is known to run on 5432, so software anticipates that. We also need to specify the name of the database, as well as the user and the password for that database, because Postgres is this server. It contains multiple databases simultaneous, potentially, and we can have different users that have different access to different databases and different permissions and so on and so forth. It's much more full-featured and complicated than SQLite. So this is how we would describe our connection to Postgres. But how do we get Postgres running? Well, if you installed it using the standard methods on Windows, Mac, or Linux, you will have installed Postgres. You should have a process up and running, and you should be able to connect to it using port 5432. The user should either be Postgres or your username, depending on how you set it up, and then the password is going to either be your password or the administrator password on your computer. Those may be the same things. Now, we should never check our password into source control, like I am going to be doing here, but this is a development thing, so I don't really care. The other way to handle Postgres is with Docker. Well, not other way, one of the ways. So the idea is we often have this complicated software that we want to run in our computer that takes some work. I'm sure some of you had issues installing Postgres, and some of you on Mac and Linux, I don't know how specific it gets on the Windows side, but setting up Postgres correctly can involve mucking around with, users on your computer and learning commands like su and sudo-u and just, some complicated Unix administration things. Alternatively, we have this tool called Docker, which lets us essentially package up our applications into these tiny little virtual machines called containers. And then we can download and run them, and they contain all the dependencies they need, and our computer can connect with them through the network or through the file system. And that's exactly what we can do with Postgres. The way we do this is you have to have Docker installed, and then once you do that, you have access to the Docker command line interface, which I'm going to be prefacing all my Docker commands with sudo, because it requires the administrator permissions on my Linux computer. I do not believe you have to do this on Macs. I could be wrong. And you do not have the sudo command on Windows. If you get permissions errors, then just run your git bash terminal as an administrator. And so what Docker lets us do is download these containers people have already made over the internet. So I can do docker pull Postgres. And I'm going to move this actually up because I'm blocking it in the recording. And this will download an image of a Postgres container containing Postgres and all the things that Postgres needs to run. I'm not going to do that because I've already done it, but you would just see, a loading screen telling you that it's downloading. And then we can start a new container running Postgres. So we would do this by saying docker run, and then the name that we want to call this container, and I need to mute my Slack notifications. There we go. I'm going to call this Docker, let's call this Booker Postgres. That's going to be the name of this container. Then we can also specify environment variables that we want to send to this container, because it's going to use these to set some default information about our database. So one of them is the Postgres password, which we can set to be whatever we want. In this example, I'm going to be using Docker, which is what I have in my configuration for Next. We can also set other things like the, what is it, Postgres DB, which will change the name of the database that we're connecting to. Let's call this Booker, which was the name of my Build Week project. And then we can also change the Postgres username. I'm going to leave it as the default, which is Postgres. And if we do not set this Postgres DB environment variable, the username will be used as the default name for the database. From there, just trying to make sure I have all of my command line flags right. There we go. We use the flag -d to indicate we want this container to run in detached mode. Otherwise, yeah, it just runs in the background when we use -d, which is fine. And then -p. What -p does is it binds ports. So, you know, when we run our yarn start or our node server, we specify the port we want our process to listen on. Well, because our Postgres is going to be running inside of this container, it has its own set of ports. And Postgres is going to listen by default inside of there on port 5432. But that's inside the virtual machine. What Docker allows us to do is to specify a port on our computer. And that is going to essentially mirror the connection inside of the VM to our port. So what we could do is just trick our computer into think that we're running our own Postgres install locally by setting our port on the left-hand side, 4532, to be the same port on the inside of the virtual machine, 5432. I think I've flipped my 4 and 5s when I said this one. I actually have a Postgres install running, so port 5432 is actually taken. So I need to specify another one, and it's literally as easy as just picking another one. 6234 is what I've decided to use. 6234. There we go. And then we specify the name of the container that we would like to use, which is going to be Postgres. Why didn't it like this? Oh, I need another -e for this environment variable. And then I'm going to need to run this with sudo in front of it. And it's going to take a second. Now we have a working installation of Postgres running on our computer. I know it was a lot of stuff to configure, and I'm going to drop a link into the channel, and it will be in the description of the video, to a nice little article about setting up Postgres with Docker. But we now have a Postgres database running on our computer, and it automatically set up creating the database, creating the users, giving them permission to the database, and all that, which is pretty neat. If you've gone through manual Postgres administration before. There's a couple advantages to this solution. One is that we can very easily spin this Docker container up and down, depending on the project we're working on. We can also have one per project and just kind of isolate it. One of the difficulties of working with Postgres is that if you muck things up, it can be harder to just delete the database file and start over. But if you're using Docker, we can literally delete the container that we've just started by doing docker rm and then our container name, Booker Postgres. We can also see running containers with sudo docker ps, which will print out all of the running Docker containers. And there's also one that I had for testing that's actually still up on another port. So see, we can very easily have multiple of these running at the same time. We can delete them, we can pop them back into existence. The article I linked to even shows we can have the container delete itself when it closes, but using the same kind of mirroring we did with the ports, we can have it save its data somewhere on our computer so that we can very easily spin up another container and use the existing database. So, do we have any questions thus far?
Yeah, Henry, is there a graphical interface for Docker, or is this all command line based?
There may be a graphical user interface. I don't know. I just use the command line because it's ultimately what I'm comfortable with. But there's one other very strong advantage to this command line. We could have this container automatically delete itself when it's done, because otherwise it's going to take up space on our computer, by adding the --rm flag. And you know what we could do with this command right here? This long, ugly, boring, hard to remember command. We can put it in our scripts in our package.json. We could just have a script that's going to spin up our Postgres instance. Once that's done, it could automatically migrate and seed it. Like I have a command here which performs migration, seeding, and then starts up the server. So you can very easily do that. Or you can save it into a bash script to be able to run it again. And also, once this is created, if you do not have the --rm, you can just say docker start and then the name that you have given this, and it will start it right back up where you left off. And let's say I wanted to stop this. I can see that we have both the container ID and the name. I can just grab the first few letters of this container ID, bd6, and then say docker kill bd6. It's going to go offline. That's it. It can be a bit more complicated to shut off and restart a Postgres install natively, because you have to use whatever service thing comes with your computer. I have no idea what that's like on Windows, and on Mac I don't either. On Linux, it you know, you have systemctl and things like that, and it's not always super easy. But I can just do sudo docker start booker Postgres, and hey, it's running again. All right, so how many of you were able to get Docker set up successfully? Any of you?
Yeah, I didn't get a chance to get through it.
Okay. Well, I mean, either way, it's a cool tool. You'll be able to see it. Once we get our connection up, there's going to be no real difference between using Docker and using a normal Postgres install, or Postgres somewhere else on the network. You know, oftentimes a company will have a staging Postgres instance in the internal network that you can connect to, right? Part of our next config is this port, but we can also specify a host, which doesn't have to be localhost. But we should have a connection ready to go here. So then in my terminal, I'm going to run npx next migrate latest. And we'll check and see, hey, it worked. Just the same as it did with SQLite, right? Once we're connected to the database, it's pretty much the same. And I can also do seed : run. Yay, my seeds worked. So I want to show you the first thing that can go wrong with the compatibility between SQLite and Postgres, and that is truncating when you're adding seeds. So very similar project setup to normal. Inside my data directory, I have some seeds. I have actually two seeds folder. The normal seeds folder I ended up using for testing, and then I added another seeds folder for production seeds. You can do that very easily by just having a different directory for seeds for your different database connections. So yeah. So in prod seeds, I have this down file, which is what we'd use to truncate out the database. And now normally, that should be yeah, I see why. Okay, so normally we would do .truncate here, right? And we could chain .truncates inside of other .thens. So I could do .then, next, let's say I want to get rid of the books table, and we could do truncate. This would need to be wrapped up in a little arrow function here. If you run this on Postgres, you're going to get an error. And it's going to be pretty cryptic, and it's not going to tell you how to fix it. Basically, the reason is that when we truncate on Postgres, it does not automatically restart the identities, which is going to mess up seeds. And you can also specify how cascading works when you truncate in Postgres. So there is a command in SQL, it's truncate table, and then the name of the table. And in SQLite, that works great. Automatically restarts the identity, automatically cascades, all that good stuff. In Postgres, you need to manually specify that you want to restart the ID auto-incrementation, and then also perform cascade. So you can do this with a call to next.raw, which is just allows us to build a raw SQL string that says truncate table, restart identity, cascade. And if you want to know how I learned this, I just Googled Postgres truncate and read the Postgres documentation. Documentation is your friend. So truncate optionally takes the word table, optionally takes the word only, the name of the table, or more. And then these are the other options. So we could either tell it to restart the identity or continue the identity where it is, which is the default. And we can choose to either cascade or restrict. So we build this next.raw call. I just put it in a function so I didn't have to keep saying it over and over again. And what we could do is we could do something like template strings here. And I could use the argument of the table name inside this string. And this would work perfectly fine. And in here, there is no problem doing this. Generally, though, we really strongly want to avoid building our own strings when we do raw SQL queries into the database, because this is how SQL injection attacks happen, where someone could, pass in as an argument to table instead of a table name. Well, what if they made it like star, and then suddenly they truncated all the tables, but I wanted to do just one or something like that. And in this case, we're fine because this function is not exposed to user input. So we don't have to worry about it. But instead of this, we can just kind of use by default this string expansion, string interpolation process given to us by Next, where we can use question marks or double question marks to send in values or identifiers into our SQL query, and it will escape those properly to prevent SQL injection attacks. And then we can supply them in order inside of an array as the second argument. If you have just one, you don't have to put it in an array. And so this is how we truncate our database with Postgres. And note that this is probably slightly incompatible with SQLite if you try to use the same thing. And that's why we resort to using SQL Cleaner, because it will automatically discover our database connection type and then use the appropriate truncate function there. But this is how you do that manually. Any questions with this?
So if you run the cleaner on a Postgres database, you're saying it is going to truncate, or it's not?
what the cleaner does is it truncates any tables you want it to truncate, and it uses the appropriate SQL to perform truncation. Now, what Next largely tries to do is allow us to build SQL queries that are compatible between the different database implementations. Truncate happens to be uncompatible, so we either have to use a package like NextCleaner, which handles that layer of compatibility for us, or we can write our own raw query that does it. And this is pretty much, if you look at the source for NextCleaner, it's 2 JavaScript files outside of tests and stuff. And they do basically what I wrote here.
Right. Okay. Also, how did you know? Like, how do you know it's valid to just put a function, the PG truncate? I mean, how do you know that's going to work?
This is just JavaScript. Right. So the idea is that when we write our seed and migration functions, we perform some operations on our database, and they have to return a promise. Because when we invoke them with Next, Next won't know until they're done until the promise resolves. So I can do anything that I want inside this file as long as I return a promise that resolves when any operations I've done on the database have finished. Now we can use our Next queries in here to do things like next.truncate or next.del, which return promises. And when we do one per file, it's pretty clear how this works, right? I do booksauthors.truncate. That's going to return a promise. When that promise resolves, Next is going to go ahead and run our next seed function or our next migration or whatever. But what we can do is if we have an existing promise and we want to do something after that finishes, well, we can put a .then on there. And I don't care what the value the promise resolved to was. I just care that the previous promise I had started has finished. So then I'm going to do another thing that returns a promise. And this PG truncate is just a function that makes a raw next call, which ultimately is going to be the same thing as any of the query built next calls that we make. And then when that is finished, we'll move on to the next table in our database. And we could write a more complicated function to do this if we wanted to. This is just pretty straightforward. The way I approached it. But yeah. Does promise.all do them in order? It depends on the JavaScript implementation. I don't know if they necessarily execute in order on Node.js. So I'd have to look into that. But potentially yes, potentially no. I believe the documentation for promise.all says you should not rely on the behavior of them completing in order because that's not part of the specification. So I would be hesitant to do that. But another very simple way to do this is with async await, because we don't care what the promise this function resolves to at the end. We can just make this function async, which is automatically going to return a promise, and then we could just await each one of our PG truncates. And that's going to just look a little bit cleaner than have all these .thens in there. All right. Any other questions with this? Raw SQL queries are cool. We're not going to see the end of them just yet. But that's it. If we look at our migration here, it's pretty much the same as the one we have for SQLite, except strings versus text and stuff actually matters here. And we saw this before in some of the earlier projects I did where we have books, and books can have multiple authors, and books can have reviews, and so on and so forth. We see another call to raw in here. One of the other instances of incompatibilities I ran into, it was making derived unique indexes. So I wanted to make it so that each textbook title could only have one edition, but what if someone inputs a title that just is, an existing title completely uppercased? And I actually should have included the ISBN in here because title shouldn't be unique. But we can create a unique index that relies on 2 columns. and also run functions on some of the columns. So I can lowercase the title here. Now this, using Next's query builder, this worked fine on SQLite, but Postgres did not like it. So I basically just had to rewrite it using a raw SQL call, which, as you can see, it looks pretty similar. And there's tools that will allow us to run a next query and then print out actually the raw SQL that it's going to execute. So don't be afraid of raw calls. They're not that bad. But this is really just a tangent. Just, other than that, literally the entire database schema for this project was identical, and I didn't really need that unique constraint. I could have lived without it. What did I want to show next? Yeah, I want to dive into SQL land for a little bit, because I want to talk about a problem that is near and dear to my heart that we don't have the time to touch on in the guided projects and stuff. And that's what happens when we do some joins. That's what happens when we do some interesting things with joins. So I have already set up a server.js, and that is going to point to a books router that I wrote, and I'm going to pop in there and see, it's in routes and in books, and we're going to take a look at some of the stuff here. Now, I guess I already have some of my existing code in here. We're going to ignore that. I just want to write a I'm going to start Insomnia while I'm at it. I'm just going to write an endpoint, router.get. That's going to be on root. We're going to take our rec and our res, and I want to return all of the books. And I have to launch Insomnia twice sometimes. I don't know why. Or is it already open? Do I have Insomnia somewhere already? Maybe 3 times is the charm. There we go. And what I want to do is I want to return all of my books. So I've required the DB in here. I'm not going to jump between model stuff. What we're going to do is we're going to do DB of books, and then we're going to get our books, and we're going to do res.json and give it the array of books that we get back, right? Simple enough. Works the same no matter what our database connection is. And I'm going to need to start this server. Let's go ahead and do that. And yarn server. There we go. So let's go ahead and get our books. So we have it. We have our books here. But we're missing some information here. Mainly, the thing that jumps out to me is the authors. Right? There's no authors on these books. And that's because books can have more than one author. And I have to do a many relationship on there, because authors can also write more than one book. So in order to get that author information, I'm going to have to do a join. So we can do this in a rather simple fashion of just doing a jot join on here. And the table is going to be books authors. That's our intermediary table. And I want to join where the books authors dot book ID is going to be equal to our book ID. Or this should just be books.id, excuse me. So now we make the query, and we're going to see that we do get the author information on here. But for each book, we see that we have our author ID, and then if our book has more than one author, this is going to repeat. Let's find a repeat in here. Come on. Where are repeats? Oh, it's doing weird things with IDs because I just selected all. But let's search in here for algorithms, because I know that has multiple authors. So introduction to algorithms, introduction to algorithms, introduction to algorithms. So this book actually has 4 authors, so it shows up 4 times, right? Because when we do a join that is one-to-many, we can only have rows, right? So if we have one row being joined to multiple rows, we just create, that number of rows with the additional information added onto it each time. So this isn't a solution to what I want inside of my representation for JavaScript, which is a subarray. And I'll get to that in a minute. But for now, what I want to do, since this seems like a hard problem to do a subarray, either I need to make a whole bunch more queries to the database or something like that. What I'm going to do is I am just going to count the number of authors that each book has. So we remember the count function from our normal SQL adventures. Next offers us this .count method, and I can specify, I believe, the column name that I would like to count. So I'm just going to have this be books. I'll just have it be star. And then I believe the second argument is what I want to rename this column. We should always be double checking our next docs, because I used this recently, but I can never remember. Okay, so it looks like I can do as the second argument as, and then this. Or okay, I can do this in here too. That's what I thought. So my Slack just restarted for some reason. And I'm going to say this count as num authors. And then whenever we need an aggregate function, whenever we have an aggregate function, we need a group by. I'm going to group by our books ID. And now when I make this query, we can see we get the number of authors for each book, and we lose all our other information. When we do a count, this implicitly is going to write to our select statement, right? Because we do counts inside of selects. So we can no longer rely on our DB of books to handle doing a select all for us. I'm going to get a limited set of information here just to make the output a bit more readable. I'm going to get the book's title, and honestly, that's it. That's it for now. So now we can see that we get our books and the number of authors that they have. And I no longer have 4 repeated sets of introduction to algorithms. I just have the number of authors being 4. Some of the studious members of the audience may have noticed that this number is actually a string. This is another difference between Postgres and SQLite, which is that Postgres can support a whole lot of data. So by default, the value that it returns for a count operation is potentially up to the size of the maximum number of rows that Postgres can represent. And that value is called a big int, and it is potentially much larger than the size of integers are inside of JavaScript. So in the PG client, it will transform big ints into strings. You would just have to write you can write pieces of middleware for the client, and I'm not going to go into that here, or you could map over this and parse these into numbers yourself. But some subtle differences between these things. Ultimately, it shouldn't really matter in this case if they're strings or numbers or not. I'm not intending to do a lot of math on it. Just wanted to mention it. Chris asked a question, if this supports Json, couldn't we just have an array of IDs for our many-to-many relationship? Well, that's essentially what our intermediary table is. Postgres does support JSON as a column type. You can just insert JSON into Postgres and do cool things with it and actually query inside of the JSON. Take that, MongoDB. But we wouldn't usually want to do that to encode our data as we normalize it. the recommended use cases that I'm familiar with is really when you're querying data from some other service and just kind of want to dump it into your database without having to, normalize it and build schema for it, which might be useful, like client side. SQLite can also support JSON as a column type with an extension and do similar things. And we could do that here, but unless there's some compelling reason for you to not build out tables and actual schema for things, I would stick with that before dropping in JSON to places to replace relationships rather than, you can drop in a JSON column to hold some data if, that's what you need, but I wouldn't use it to replace relationships unless you have a compelling reason to do so. Yeah, so got our authors. Anyone have any questions with this join? Should be pretty basic join and account. Okay, well, what I want to do is, I also want to know how many reviews that each book has. So I'm going to do another join, right? So I'm going to do a .join, and I'm going to do this on the reviews table. And this is a one-to-many. There's no intermediary table. Each review has a book ID, and I'm going to get it where that matches our book's ID, right? And then I want to do another count, and I'm going to do another star. And this is going to be as, we'll count the, let's count the review IDs, and then we'll count, we'll say this is num reviews, right? So we should get, the number of authors that our book has, and then the number of reviews that our book has, right? That's what I'm doing here. That's not what we get. That's not what we get. Suddenly, Introduction to Statistical Inference has 4 authors, where I don't think I had that previously. Let's undo. Let's check. No, it had 2 authors before. So why would it have 4 authors now? Does anyone know?
Could you repeat the question, please?
So when I'm just counting the number of authors that are in the book, which is what I do with my first join, Introduction to Statistical Inference has 2 authors. And Cracking the Coding Interview has 1. Introduction to Algorithms has 4. When I try to count the number of reviews each book has as well, suddenly our first book has 4 authors, and Elements of Closure now has 2, and everyone now has, it seems, more authors than they did previously.
It's running the count twice.
So it has to do with the count, kind of, and I somewhat masked the issue by counting the reviews ID, right? I'm trying to count the number of reviews here. When I was trying to count the number of authors, I just used stars because I was interested in the number of rows for the book. And technically for here, doing this is the exact same as doing a star here. What happens is that these counts are performed after our joins. Right, the join builds up this table for us, and then we select items from it, including our aggregation functions. So what happens here is, right, when I did the first join against book authors without doing a count, we had each row duplicated for the number of authors that the book had, right? So for algorithms, there were 4 rows because it had 4 authors. And then we aggregated that down into a single row with our count. Problem is, it's common here to think sequentially, and it's like, okay, so I aggregated that down. Now I want to join in the reviews that each book has, and then I want to count the number of those rows. But that's not the order of operations here. Both of the joins are going to happen. And what you're going to get here is a cross join, where you have you know, 2 or 3 rows per book because of the number of authors that has, and then you join a bunch of reviews in. And so you're going to get more rows than you would off of either join because you're duplicating the joins for every row. You're performing the increase in the number of rows. Instead of 1 book to 3 reviews, you now have 3 copies of the same book with different authors times 3 reviews, and now you're getting a bunch more rows. So doing multiple joins between one-to-many relationships can be tricky because you cannot do it like this. You cannot do it like this. You can Google for solutions, and there are tons. There's absolutely tons out there. Because SQL is a very full and complex language that allows you to solve problems in many different ways, like JavaScript. A way that I like is with the subquery, which allows us to, inside of our SQL statement, to just make another query and produce another bit of data, perhaps a table, and then join that. So this looks like, it's called a with statement. So I'm just going to pop open the Postgres documentation for that real fast. So what it allows us to is specify for some query that we want to run, we want to do it with some data that we're about to construct here. So we can create a fake table called regional sales, and then we can define it via a subquery, another select, which is going to produce data, and it's going to pop it into this table. And then we can join this table or do other things with this table as we see fit. And so subqueries will allow us to aggregate things inside of a smaller select statement so that we then get a one-to-one relationship when we do our join. So we won't get a cross join. I'm going to do this, and hopefully it makes more sense as I get into it. So the syntax with next is a dot with. And this takes 2 arguments. The first is the name of our table, which I'm going to call A. I'm going to call it A for authors. And then we expect a callback function here. You could also just write a raw query in here. The callback function is going to let us build a query, much the same way we do with DB in here. The docs call this QB. I'm not actually sure what that stands for. In my mind, it's like query back, right? It's a query version of our database. And it's virtually identical to this DB, except we can't use it as a function. So I cannot do books authors. I'm sorry, QB. Books authors. But that doesn't really matter because that's actually a shortcut for .from books authors. So don't know why that's the case, but it is. So what I want to do is I want to select from books authors, and I want to count the number of rows as the number of authors, and I want to group this by the book ID. Right, same thing we've essentially done out here, where we made this join, regrouped it by the ID of our book, and then we counted. Now I'm doing this in this subquery, and what this is going to produce is 1 row for every book. 1 row for every book that contains the number of authors that that book has. And now, instead of making this join to the number of authors, I can make this join to A. Now, small thing that's going to trip us up here. I'm going to do it and show you the error and catch any errors that I have mistakenly done as well at this point. Where I want to join A on a.bookid on our books.id. Let's go ahead and make this query. And all right, we got one error. Hopefully it's the one I expected. Yes, it is. So column a.bookid does not exist. We run into this same issue with this dot count. This dot count is going to implicitly set our select, so it's no longer getting everything. So I need to perform a select, and I want to say explicitly I want to get the book ID. And you know what? While I'm at it, I'm also going to get the author ID. No, I don't want the author ID. That is not going to be helpful because of the way I'm doing aggregation. So now, when I send this request, there we go. I'm getting nothing here because I'm not selecting it. So we expect this table A to have a row called num authors. I can add that to my select statement, and then we're getting an error here. And so this is a subtle and very frustrating error. And it says, I don't know if it's difficult to read. It says column a.num authors must appear in the group by clause or be used in an aggregate function. And this basically has to do with the way that Postgres handles joins and group bys and things. And you won't see this error when joining against real tables, but Postgres has difficulty inferring the primary key of tables we create via subqueries. The simple answer is that we can avoid this by handling all of our joins in subqueries, or I can add to this group by, I believe, a.bookid, and it will work. Nope, it still didn't like that. I think I need to do a.id, and then also select the ID as that's the primary key of this row, and I think that'll do it. Nope, shoot. Oh, now it wants books authors ID. Yeah, it gets weird with this, and we can put a.num authors in here, and it should make the error go away. Nope. Yeah, it still wants it in the group by. So our solution to this is to just handle our joins, you know, via these subqueries. And you can Google it, and there are ways to get around this whole must appear in the group by thing. But if I just take out what I'm doing with the reviews, because the issue is, I'm sorry, it's not to do with the joins. It's doing another join in another aggregation against the main table. That's what messes it up, is when it's handling that group by. So we can just remove the reviews stuff for now, and this request should work as soon as I fix these why doesn't it like this? Do I need to specify books authors.bookid? Yep. This is the thing with doing this live. This should be totally fine. Oh, what if I remove this? Nope. Uh-oh. Okay, now what if I take this out? There we go. Whew. Whew. Okay, this see how I told you that's a very annoying error? It is. So doing no aggregation, doing no group bys in this, I think it did not like how the subquery generated some columns that were identical to the names as the book columns. So when we were getting the ID, it was causing issues with it recognizing the primary key of our books table. That's my guess. I don't know. But we get our number of authors. And I'm joining against the wrong thing. This should be book ID. So wondering why all the authors were 1. There we go. Wait, those values are also incorrect. group by book ID. This should be correct. Oh, I wish I had more time to prep for these. Let's see. I believe I still have the function that I wrote for this. So this is select from, and then we did a join there, and we group by that. Oh gosh, I'm not a smart man sometimes. I'm joining the book ID against the book ID. Oh, so they were all just getting the first one. So this should be books.id joining against the book ID. There we go. Whew, now everything's correct. Intro to algorithms, 4 authors. Intro to electrodynamics, 1 author. All right, sorry for that excursion. But how are we doing with this? Performing our subquery and then joining this table that we just made, A, against our books as a 1-to-1 instead of a 1-to-many.
Why in the connects? Why do you have a callback function? How would it look in raw SQL?
I would just have to do something like db.raw and then say like select book ID comma count star, and I would just write this query within raw SQL. If we want to continue using our SQL builder, we need the callback. And I could do this, but might as well use the SQL builder while we have it. So, yeah. Yeah, so we're constructing this aggregated table here and then joining it on here. And that's
so whenever you do a is this like a nested query?
So it's a nested query in the sense that if we look here, that the way it looks in raw SQL is indeed, this is our normal select statement. And we're literally just having additional select statements make these other tables for us. And then we can use these tables within our query. So it's using this to, in here, check whether the region in some orders is in this fictitious table top regions, which is being generated with another select query. So it's a nested query in the sense that, like, yes, literally we're nesting select queries. It's not a nested query in the sense that we are not sending 2 requests to the database.
Oh, I see. Yeah, that makes sense.
Yeah, this all gets turned into 1 SQL string, and that is sent to the DB.
Right. And how does this differ from the union?
A union is a way of kind of joining and reconciling data as a set. This allows us to produce a table that we could also use in a union if we wanted to. This just allows us to treat derived data as though it were an actual table. So if I wanted to, within JavaScript, I could keep track of the number of authors each book has. And when we add a book to an author, I could query the number of authors in the database, and I could, increment that or decrement that and then put it back in our database. But we don't really want to store derived data like that in our database because it can easily become out of sync with the data. Instead, we would prefer to have our database calculate that information when we request it. And so one of the ways to do that on the fly is with this subquery, where I can essentially do an operation to create columns that didn't previously exist, like our count and our aggregation functions allow us to do. But instead of producing a column, I am producing an entire table. And so that's very cool. You can also permanently create a table using this derived information via something called a view. And SQLite and Postgres both support views. I don't know how compatible the syntax is between them. I have not done it with Nex. But it allows us to, in essentially the same way, create a table, in this case called vistas, via some select statement, here we create a view called comedies, and we're creating this select statement. So we're finding all the films that have a type of comedy, and we can now treat this table comedies as if it existed. We can't do insert or delete operations on it, but we can query data from it as if the table existed. And the data doesn't actually exist as it's stored in the database. It will perform this select query in order for us to go and get the additional information on it. But that lets us essentially store derived data in our database. And so this with statement allows us to create these tables on the fly. This view statement allows us to create these tables permanently. What Postgres supports that SQLite does not is materialized views, which is a way of having Postgres keep track of this information for us, but actually store it physically in the database, so we don't have to constantly recalculate that when we do our queries. And so this is a very common feature that people use to make Postgres very efficient with large data sets, because you want to know how many likes a post has, but you don't want to store the number of likes. You want to count the number of likes. But what happens when they have thousands of likes and millions of tweets and things like that? Well, you could store that information in a materialized view, which will let Postgres handle the actual updating of these values instead of recreating them on any query. So it's very cool.
And how is a view different from just selecting some data?
It's not, other than the fact that we can use it semantically like a table that already exists. So instead of performing this, I don't remember where it was. Yeah, selecting all the comedies from a film. If we do this frequently enough, we can just use this view syntax to create a table called comedies that is populated by this query and then refer to it by the name comedies. So it's you can think of it kind of like a variable, right? How we'd want to store some data that we're going to frequently reference in JavaScript. So we do this. Technically, this is more like a function because it is performing this select, but we treat it like the output. We can just join against this table and select things further from it and do whatever we want. And this is kind of what helps us build like things like dynamic queries on the SQL side. Where we could use next to also make a function that's gonna do this query for us and reuse that. The advantage is that now we can do this within any arbitrary query without importing that function. But the real big advantage is the materialized view, which is going to persist that data inside of the database instead of recreating it on every query. So I'm not going to get into how and when to do these things. I just kind of want to mention some stuff that we didn't have time to in lecture. So subqueries, views, very cool things. Let us do a lot of powerful stuff. And let's do the same thing real fast with the reviews. So I'm going to create a table called R for reviews, and I'm going to give it this callback function. And I want to, on our QB, I want to perform a select operation. I want to get the review ID. And let's get the book ID. And then instead of doing count for this, I'm going to perform an average. Why isn't it liking this? Did I mess up my syntax here somehow? Oh, I have an extra quote. Instead of doing a count, I want to do an average. And we have the AVG function instead of count. And I want to average, in my reviews, there's a column called rating. So reviews.rating as average rating. That's what I'm going to choose to call this. I want to do this from my reviews table, and I want to group this by the reviews.book ID. And then same thing here. We're going to do a join against our table R, and I want to join where the book ID is equal to the review.book ID. And now when we send this GET request, we're getting some error, probably because I did something slightly wrong. Oh, this is, I don't want the review ID. That is the ID as the review ID. And what's it not liking now? Oh, it's not liking group by things. Why is it? I'm going to just get rid of this for now. There we go. So now I can add this to my select, and I'm going to get r dot average rating. So there we go. We get our books with the number of authors that they have and the average rating of that book. Pretty neat. Pretty neat stuff. And this is a very simple join. These are both one-to-ones. I want to point out something, though, that can bite you during build weeks, which is I've been just using this .join here. Just this default .join, right? Good enough for me. Join. I want to join a thing. I'll join it. This defaults to the inner join, which means that it is only going to produce rows that have both sides of the information. So what we're going to get here is books that have authors, which should be all books, right? But also books that have reviews. So if a book doesn't have a review, the result of this join isn't going to exist. We're not going to have a review that has our book ID. So instead of using a join here, an inner join, I want to use a left join, because what the left join is going to do on our Venn diagram of joins is the inner join, so this is our books, and this is our reviews. So our inner join, our just default join keyword, is only going to get these, right? Books that have reviews, which sometimes this is what we want. It's kind of basically like a default filter. Like if I'm interested in, sorting by the books that have the most reviews, then I only want books that have reviews, right? But if I'm just trying to get all books with this additional information here, then what I want is the left join, which is going to get everything in this left circle. All of the books that have and do not have reviews. So we're going to see as soon as I make both of these left joins, also the authors, because here's where I erased this. Because I actually have some books in the seeds that don't have authors. We're going to see that we actually get more books, mainly the fake book that has no authors and no ratings, but I put in here in order to serve as a canary for whether or not I was doing joins the way I expected them. And we see that not all books have ratings. This Rust book, no ratings yet. So left join. Important to know the differences between your joins. All right, questions on that? Okay, now I want to do the real cool thing. The real cool thing that I was here for. I don't want the number of authors. I want the authors for the books, right? I just want a subarray that has the authors in there. Shouldn't be that hard, right? Actually, kind of that hard. Because we have no notion of that, right? This nested array. Some SQL dialects will often have an array aggregate function that will allow us to append values into an array. And I could use that to get a list of the authors' names, which is pretty cool. I don't know how well supported that is in SQLite. It is in Postgres, but Postgres has functions that lets us build JSON arrays and also JSON objects. Unfortunately, it's not supported by the Next Query Builder. And I think part of that is because a lot of databases have been implementing these JSON functions, and not all of them have them yet. And I'm guessing Next is going to wait until the dust settles on that before trying to enforce some standard compatibility between them. Even if they don't, we have our raw queries, and it's totally fine for a raw query. So first, I want to rewrite this count as a raw query. And this is as easy as inside of my select statement, I'm going to do db.raw, and then I'm going to say count star as num authors. And that's it, right? Inside of our select statement, when writing raw SQL, that's where we put our count statement. And works the same way. We just have to specify that this is a raw item within our select rather than just a name. So That's how we do that. But I don't want the number of authors. What I actually want is to create a JSON object for each row. I'm going to do this with the function JSON build objects, I believe is the name of this function. And this is why it's important to have the documentation up. Build object. Yes, it is. And then I can specify key value pairs. So I'm going to have this actually surrounded by double quotes, so I can use single quotes on the names. So I want to have a key called ID, and I want its value to be the book's authors dot author ID. And then I want to have a another key called name, and this is going to be the book's authors dot name. And this is going to produce a JSON object for this row that has the key's ID and the key name with the appropriate values. While I'm here, while I'm doing this aggregation, I can wrap this in another function called JSON Ag, which aggregates record values as JSON. So this is going to turn this into an array of JSON objects. And instead of calling this num authors, I'm just going to call this authors. Change this up here too. Oh, probably just did something slightly wrong. Books.authors. Oh, it's because I have to do a join here. Aha. So this is another reason why these subqueries are really good, is because I need to do another join. And I'd start having lots of joins out here where it would get, kind of complicated to tell what's happening. I'm right now doing a query on my intermediary table, but that doesn't have the author's name. That happens in the authors table. So I can just do a join here, and I want to join against the authors table, where the authors.id is going to be equal to our book's authors.id. And now I can select the author's name here. And we see in this response, we get our book, and we have authors as a key, and it has a nested array of objects in here. One query. One query. Look at how sick that is. That's incredible. Right? This is really, oh gosh. I don't know if you were all muted and just like, oh, freaking out, because this is freaking me out, man. This is the best. These JSON aggregate functions. Right? It totally blasts away the impedance mismatch for me of, organizing data in tables and not having this kind of sub-array relationship. Boom, we got it. We got it. That's it. Any questions with this? Oh, I saw Eli. I'm sorry, I just saw this now. Why isn't author count 0? That's just the way that the count functionality works. If it doesn't find any of those rows, there might be a way to set a default value for that column so that it will be 0 instead of null. I don't know though. I'm sure there probably is. But yeah, JSON aggregates. This stuff is super dope. And as you saw on the documentation, there are a lot of other functions that Postgres has to do stuff with JSON, including storing columns as JSON and then querying stuff about them. There's also the JSON1 extension for SQLite that lets you do some similar things. And at this point, there's a good chance that you have this SQLite extension automatically installed. I just don't really know the process for making sure that ends up on your deployment as well. I think you have to manually compile the extension and then require it. within your database connection, I think, but I'm not sure. But you can do some of this similar stuff within SQLite if you really want to. And you can check that by doing SQLite 3 pragma compile options, I think is what it is. Yeah, there we go. And you can see that I have enabled JSON 1. So, yeah. All right. And to wrap us up here, I'm done with my database. So I'm going to do sudo docker ps. And I'm going to do sudo docker kill Booker Postgres. And then you know what? Sudo docker rm Booker Postgres. Never going to see that again. If I need to, I can just make another Docker thing for it. And it's going to be no big deal. So that's it. That's your brief tour of Postgres. Any questions?
Yeah, I have one more question about Pragma.
Mm-hmm.
So what exactly does Pragma do?
So Pragma allows us to like run commands that aren't like SQL commands and get you know, data and, you know, set properties and things like that. I don't know why it's called Pragma, but yeah. So it basically just allows you to set settings and query settings and certain other types of data on your database. So that's where non query stuff goes. So this is used by you usually when you set up the database in order to do certain things or to read certain properties of the database, like statistics and the schema and you know, information about like the version and stuff like that is all done via pragmas. All right. Anything else before we wrap this up? Okay. I don't know how useful this was. I hope you enjoyed me just kind of poking around at this stuff. I think Postgres is really cool. I think the JSON aggregate functions are amazing. And hopefully it demystifies a little bit of the Postgres stuff. It really is. Just got to figure out a way to get it installed and running. The connection stuff, you know, requires a couple other setting tweaks. Occasionally you're going to have some SQL mismatches. Usually that can be solved by some Googling and a db.raw or a package like NextCleaner. But you also get cool things like these JSON aggregate functions. And I hope you learned a little bit about subqueries. And if you're looking for more cool SQL to learn, read a bit more about subqueries, read a bit more about views, and then something we also get in Postgres that we do not get in SQLite are window functions, which allow us to grab data from other rows. So for example, we can like find the previous value of a row and then, you know, do like subtraction against it and find how much more, you know, we're making than the previous item or something like that. Or like find the average for a whole department and then, you know, include that on every row for every user who's in that department. And we can also sub that with subqueries. But, you know, just more tools in our toolbox. Window functions are pretty cool. Yeah, kind of like CSS pseudo classes. Yeah, so window functions, pretty neat. I read an article a while back about window functions that was actually pretty cool. I'll drop that in the channel and try to remember to put that in the description. But yeah, that was it. I will see you all tomorrow.
Can I bug you about something?
Oh yeah, sure. What's up?
Regarding Docker, that's not required, right, for using Postgres in our backend stuff.
No, no, no. It's just kind of a way to get it running on your local machine. When you deploy to Heroku, they will have a managed Postgres instance, and they will literally give you a connection string that you just have to plop inside of your config, which I meant to mention and then I didn't. The other way to handle connections to Postgres is via a connection URL, which is going to look something like this. I think it's Postgres / your username, a password, at whatever IP address or website, and then / the name of the database that you want. And it basically just encodes the information we had in that object inside of a URL. And that's what Heroku gives to you. You can also install Postgres directly and be able to use it from that. I meant to briefly bring up this pgadmin 4, which is going to let us connect to and view some graphical information about our database. So it's going to do this, and I'm going to switch to my face in the recording as I type in my password. And then back here, and it'll let you connect to databases. This is actually my default Postgres install, but if we want to add a new one to here, we can create a server and then call this Docker. And then the connection would be localhost, and the port would be whatever we set it to. I killed the other one. I think I have one still running on 6000, and I think the password on this is Docker. Yeah, here we go. And so this is our Docker Postgres. But fundamentally, we always communicate with a Postgres server over a network port. So it really doesn't matter what computer it's running on or how it's running, as long as we can talk to it over that port. So Docker is kind of a portable way for us to build up and then destroy connections to a Postgres database. If you got it running on your local machine, great. One of the other advantages of Docker is that what happens if we need a specific version of Postgres? You'll probably install the latest version, which is great, but you might walk into a job and it's like, yeah, we're still on Postgres 9.4. And it's like, well, now I need to install that. Instead of managing parallel installs, you can just do a Docker pull against that specific version of the Postgres container. And so I have no opinions about using Docker in production because I have never done that. But using Docker to get certain types of stuff working on your machine as a dev can be a very nice experience.
I see. Thanks. I was looking into it a little bit, but there was some talk of virtual machines, so I was like, I don't know.
Yes, so it basically runs them in just tiny little virtual machines. And they're reasonably efficient, provided you have hardware that can support certain features that enable virtualization to be pretty fast. And I mean, also when you deploy to servers, like you think Netlify or Heroku is giving you a dedicated piece of hardware? No, it's a virtual machine that contains your little server in it. And so virtual machines these days are very good, very fast, pretty reasonably secure, although you shouldn't rely on that. There's some default settings with Docker that you need to take care of in order for things to do stuff well. That I have no opinion or experience about, but like on my local machine, it's great. You can also, I meant to show this as well, sorry for extending this, we can connect to a Docker container, sudo docker ps. So I have this one, Booker PG. So sudo docker exec Booker PG, the name of it, -it bash, I believe. /bin/bash. I may have the name backwards on this. Maybe it needs to be -it Booker PG. Oh, Booker. There we go. Now I'm in a bash shell inside of the container, and we can see this tiny little Linux system. And I can also open up the command line interface to Postgres, similar to the command line client to SQLite. We have one called pSQL. I need to actually become the Postgres user real fast, which apparently we do not have the sudo command. Do we have su? Yeah. And yeah, now I'm in the Postgres client. And I can see all the tables that I have. And I can connect to a table. And I can do select star from authors. So it is a tiny little virtual machine. And in the same way, I have a Postgres install on my computer, so I can log into the Postgres user and then run pSQL. And I can connect to the Booker database that I had set up when I did build weeks, and select star from authors. And there's going to be only one in here because that was my testing seed. Yeah, so that's Postgres. Docker can be nice. Yeah. All right. I think that was all the things that I wanted to show. You can do. One of the other nice things about Docker is that we could very easily spin up separate Postgres containers for testing and development. A way around that, which you can do with both Docker and with ordinary Postgres, is each Postgres server can contain many databases. So I assume I can create, a database via this graphical user interface and choose who owns it. You can also do this through the command line pSQL client. Do pSQL, and then you can say like create DB, or no, it's create database, testing 1, 2, 3. And now there's a database called testing123, and I can also create users that have certain permissions to certain databases and things like that. But you can avoid all that and just make a new Docker thing and just delete it when it spins down because you're only using it for testing. So hey, why not? And then punch all that into scripts in your package JSON, and there you go. You kind of got a little mobile development environment set up. So, all right, cool. Yeah, so that was everything for me. Any final questions? All right, cool. Well, then I will see you all tomorrow.